Hi guys, thank you and welcome to the last live session on GIS on QGIS. So a lot of people were asking me if is fire data the only fire activity is the only data that we will be working on. So today
Pulaha, your voice is echoing.
now is it okay? Is it fine
No.
now? Is it still echoing?
Yeah,
Fine at our end.
Is it still echoing? Okay,
Can everyone confirm if it's fine at their end?
I think it's fine.
Yeah.
In case it starts echoing, I'll just give me a cue and we'll try to figure out. So last class, a lot of people had asked me like if we are only going to deal with fire activities data, and I told them like we'll be looking into the raster data. So today we are going to look at a very different data set and in a very different format. So normally you will come across, like I was telling you, we were initially looking into vector data. Today we are going to look at raster data, and I'll walk you through what is a raster data. But before that, I'll share a link with you guys in the chat. So just click on that and this page is going to open, or what you can do is just just do a simple Google search saying IPCC Atlas. And as you know, IPCC is the most IPCC is the one which looks into climate science and climate change science and how climate change is going to happen. So this is one data set that they came up with, I think in 2021 or 22. I'm forgetting the exact year. But once you open this page is going to open. And what I would like you to do is you have this simple climate features, uh, not advanced, just simple for the time being. You need to get used to the data itself. So just click on simple here. Simple, just click on that. And this page is going to open up. And as you can see, like it's a map of the world. Uh, would anyone like to give it a shot, like what this data tells us about, like after looking at it at first glance? It's fine, like if just give it a rough shot, it's absolutely fine.
Temperature data.
Temperature data, yeah, good. Temperature data. So one thing is for sure that this is about temperature. We are dealing with temperature here. Anyone else?
The change, potential change in temperatures. It's written at the bottom actually. So
Yeah, it's a change in temperature. Change in temperature with respect to what?
the current temperature or over the last so many years.
Okay, so as you can see, it says CMIP6. CMIP6 is one of the many models that scientists use to model future temperature change. So that's CMIP6. It's mean temperature change, as it says, mean temperature change. So mean temperature change when the world would be warming at 2 degrees. So what they mean by the world would be warming at 2 degrees is when the world mean temperature is going to be 2 degrees above the 1850 to 1900 average. The 1850 to 1900 average is normally.
Excuse me, I am Deepak.
Let me just finish. Let me just finish. And
it is from the pre-industrial era.
Yeah, the pre-industrial era. Yeah. Thank you, sir. So 1850 to 1900 is considered the pre-industrial era. So that's it. Mean temperature change when the world would be warming 2 degrees above the 1850 to 1900 average, the 50-year average, at SSP 5 8.5. So this SSP 5 8.5 is basically one of the many scenarios that the scientists use. And the SSP 5 8.5 is the most extreme scenario where you have greenhouse gases going unabated. So there's no policy change to curb the greenhouse gas emission. So that's what it means. So now if you look at it, and what I mean by raster data is, now I'll tell you. Now, if you zoom in, you see these are all in grids, like boxes, right? Like how you would see in a PNG file or a JPEG file, like the picture is stored in terms of boxes, and the more you zoom in, the more it's going to pixelate. So that's what a raster data means. It's not your vector data where no matter how much you zoom in, it's never going to pixelate. So that's the difference between a raster and a vector data. Okay. So any questions before we move ahead? I hope everyone got a hang of what kind of data we are going to deal with today. Okay, so
Why we are studying raster data when we have vector data? Means we can map it in better way.
sorry.
Why we are studying raster data? Means it's not good pixel, so we can use vector one. Now, why we are studying this?
Yeah, very good question. Why are we studying raster data and not vector data if it's stored that way? So what happens is if you're trying to do this in vector data instead of boxes, so what's going to happen is your file is going to be huge in size because it doesn't pixelate. Okay, so and there is no end to you zooming in. So that's why a lot of times what happens is, and especially when we are dealing with temperature and all that, they store it in raster data format. And normally boundaries, or if there are points and all, that's stored as a vector data. So that's the reason. Any other question? Okay, so we'll go ahead. So the first thing is we're going to download this, and before we download, I want to walk you through the settings here. So your variable, if you come here, the variable is going to be mean temperature. You're going to check on mean temperature. Please don't check on any other variable. It has to be mean temperature. Your quantity and scenario is going to be warming at 2 degrees C, change, not value, change. Okay. And your season is going to be annual. Okay. And now we're going to come to download. Okay. And in download, you're going to see download as netcdf, download as png, download as tiff. Okay. Apart from png, you can download as either netcdf or tiff. And here's the important part. Now, when in the future, when you're going to deal with raster data, most of the time you're going to see it in this format, either a geotiff or a .net or as netcdf, and its extension is .nc. The main difference between TIFF and NC is the way they store the data, the way they stored the data. Normally, I think when they are doing with modeling, anything which has to do with modeling, when they're trying to model some data, not based on observation, but based on future modeling, that's when they use netcdf. And TIFF is not most of the time it's observation, but then again you can also save it as, you can store it as a geotiff file as well. So that's the difference. And there are slight other differences, like how they stored the data itself. I won't get into the details of like what's the actual difference and all, but for the time being, just be rest assured, like you're going to deal with either netcdf or geotiff when it comes to raster data. You can download either, but I would suggest like let's go for geotiff, because that's the most normally, like you will come across geotiff a lot, and also netcdf again, but let's just focus on geotiff for the time being. You can also download netcdf and just see what the difference it is. It's usually the same, like the data is going to be the same, but you can like whenever you have free time, you can just check it out yourself. What's the difference between
Last one is it to do with the resolution of the data?
Not really, it's going to be the same. Everything is going to be the same. It's just the way they store the data itself. Slight difference between how they store, and also NetCDF, like I said, it's mostly based on future climatic models. Okay. So GeoTIFF, you can say, is mostly based on what you have observed. Okay, like the temperature for today, and net CDF would be what's the temperature going to be 10 years down the line. Okay. So that's the biggest difference. So I'll just go ahead and download as GeoTIFF. So let's see. Yeah, it's downloaded as GeoTIFF. And I'll minimize this. I'll come to QGIS. Okay. So now let me just unzip this as well. Unzip the file. It's CMIP6 model, and here are the three contents of it. What we would like to see is the map diff. Okay, this is the one with the data. I haven't looked into what consensus is, so I'll have to look at myself. But you can also check it during your free time. So the way you load raster data is again like either you can do it from the browser panel itself, or you can just come to the folder and just drag it here in the layers panel. And here you have it, the raster data. It's currently it's in black and white, okay, but grayscale, that's what we call. That's one way of loading raster data. I'll show you the official way of loading. That's just the easier way of loading raster data. The other way is like, I'll just delete this layer. The official way of doing it is if you come here, the manage layers toolbar, under vector, there's add raster layer. Okay. Add raster layer. And it is the raster data set. Here's the three dots, and every time you see those three dots, that means that you have to click on it. It's asking you to navigate or to browse where the data is. So I'll click on that. It's CMIP6, map diff, open, and then I'm going to add it. It does the same thing. So whichever way you want to choose to load your data, that's totally up to you. It's absolutely fine. Any questions before we go ahead? Where
Show
was
me
it?
the option where you add the data.
Sorry?
From where you add the data, the menu icon.
This data?
No, data I downloaded. I have also downloaded
Okay.
in the QGIS
Okay.
update.
Okay. So if you come here, I'm showing you the official way. The other way is just you drag it from the folder where you have stored it to the layers panel. The other official way is this one. You come to add raster layer. You have this manage layers toolbar.
Yes. It is vertical in your case. In my case, it is horizontal.
Yeah, that's fine. That's fine. So add raster layer. You click on this, add raster layer. I'll just delete this to show you. So once you open add raster layer, here's the raster data set, and you have to click on this. Okay. And then you have to zoom, then you have to navigate to the map diff. That's the file that we are looking into. Then you have to click on open and then just click on add. Okay.
The raster data icon is I'm unable to see in my QGIS. That's is the issue. Yes.
Can others please
Yeah.
themselves on mute, please?
I'm unable to see
This one, the add raster layer.
Yes.
Oh, so do you have the manage layers toolbar, right?
Yes, it is in horizontal cell.
Okay. So if you so what's the first option that you're seeing? Add vector layer. Is that present? Is that
Open data. Okay. That menu is not. I'm unable to see it. From where I will get it?
yeah? So what you have to do is can someone please mute? Like I think this background noise coming. Yeah. So if you need this manage layers toolbar, you come to view. And every time you need to, if you don't see something here or here, all you have to do is you come to view and you have to see like whatever. So like here's the manage layers toolbar. So it will be under toolbars. So come to toolbars, to view, toolbars, and here is going to be the manage layers toolbar. You have to check this and you will come and you'll see the manage layers toolbar. Okay. Okay. Any more questions?
Well,
Okay.
just one more doubt. While working on the vector dataset, you told that when you download the dataset, it goes to the browser layer, then you pick it up and bring it to the layers panel.
Yeah.
Okay. But in this case, you can pick up directly linked to the layers panel.
So you can also do the same thing with, you can also, I just wanted to show you another way of loading it. So you can also do the same with the vector layer as well. And
Okay.
I'll show you again, like you can also do it here. So if I just delete this layer, so here's my home, the browser layer, the browser panel home. You come to downloads, that's where I had saved it, downloads, same IP6, map. Okay, so
And drag it.
and see, let me see. Yeah, this one, map diff, and you just drag it to your layers.
So the process remains the same, whether it's raster or vector, isn't it?
So it's the same for vector or except for CSV files. If you're dealing with CSV files, you have to explicitly tell QGIS. So that's why the process of going this comma sign that you have. So CSV file, the only way you can deal with is like you have to come here. But for other data sets, you can just like drag and drop. It's fine. Either from the browsers panel or from the folder
Or
itself
directly, yeah, or directly.
directly. Yeah, yeah. Okay, so the first order of the day is what we are going to do is right now it's all gray. Okay, so we don't understand what it means. Okay, so the first thing I'm going to do is we need some clarity, and every time you need clarity in QGIS, the best way is to actually start styling it, to have some colors on it, some gradient colors on it, so you can understand. So the first thing is map. You come to map, right click, come to properties. Okay, pretty much the same like we were dealing with vector layer, the symbology remains the same. And also like it's a very good practice to also come to check all these things, like information is where all the information is stored for the file or the projection and all other things. Right now we might not need it, but a lot of times you might have to go through the information to figure out what is what. And here if you come to symbology, band rendering. Okay, so here's where the styling happens, as in like what colors we are going to give. So right now the render type is single band gray. As you can see, it's black and white or single band gray. That's what we call. And if you click on this triangle, if you click on this render type single band gray triangle, and this is under band rendering. So in case you don't see band rendering, like if maybe you are opening for the first time and it's like this, so you have to click on this to expand. The same goes for layer rendering as well, min max value settings and all those things. So the first thing is render type. Come to render type single band gray. Come to single band pseudo color. Okay, single band pseudo color, and this will give you classes. Okay, this will give you classes, and here's the color RAM. Okay, so I'm happy with, I think, rocket, and I'll just invert the color RAM. Invert the color RAM so that so the smaller the degree is, the smaller the change in temperature, the lighter the color, and the more there is a change in temperature, which is like 8 degrees higher than your 50 years average, the darker shade of the color. Okay, and you have the mode, you can do it equal interval, so it'll give you an equal interval. So right now we have just 5 classes. Okay, or you can give continuous, and it'll be like this. So these are some of the things that you can do, and just hit apply, and let's see what happens. Apply. Okay, and now we have something where we can see, I think again the polar regions would be warming the most. Okay, and now we need some map. And another way, and I'll show you another format of vector data today, which is the GeoJSON data. Okay, and for that, let me just search here world continents GeoJSON ESRI. I'll share the link, so it's not an issue. Let me just open this. Yeah, so this opens a map of the world, and you come here and you download, and you come to GeoJSON. This is the one that when you see there are other formats as well, like CSV. Now you know CSV, what's shapefile. KML is normally used for Google Earth engine, for Google Earth if you are using. So these are some of the things that you can know. Geo package is there as well. What we are interested in is in GeoJSON. Okay, these are nothing but different vector formats. It's end of the day, it's all vector, and it's going to be the same thing like the world that you are seeing. GeoJSON is something that's used for web. Okay, so that's the only difference between like a GeoJSON and a shapefile. Shapefile is something that GIS in general understands, and GeoJSON is something that GIS understands as well as the web. If you're doing some web cartography, that's when you need GeoJSON. Okay, so you just click on download. And let me just download. It's a 6.3 MB file. And I'll minimize this. Let's see. Yeah. And GeoJSON is something you can just like directly drag and drop here. And here's the map. Here's the map of the world continents. I'll just
Can you share us the
I'll
link
share
for
the
this?
link.
For
Sorry.
this?
Yeah. I'll just share the link. Yeah, here's the link. So for Trisha, I'll just share the link of the Atlas. So you can just go ahead. So I've shared both the links here. I'll just open QGIS now. Okay. Okay, so what are you observing here? Before we go ahead,
How did you download this world continent is serious?
the world continent, all you have to do is here, if you see, you have these 1, 2, 3, this option here. Okay.
I don't see. I don't see this option. I don't know. It's a down.
So you
Yes,
don't
I
have-
got it. I got it. Thanks.
Okay, yeah. Excuse me. You have to come to download and just download the data. You can also download shapefile. It's absolutely fine with me, but I'm just like, introducing you to as many GIS data formats as possible, so that next time you come across these data formats, okay, like I've worked on this and I can load it on QGIS. Okay.
So basically, Pulaha, when we are looking for data on political boundaries, in that case, GeoJSON format is advisable. That's what you're saying?
Yeah, it can be in GeoJSON, it can be in shapefile, it really doesn't matter. Okay, it really doesn't matter. But normally what happens is like for QGIS, normally shapefile is the standard. Okay, because you're gonna come across shapefiles a lot. Okay, so shapefile is the standard, but then if it is, say, like if you're downloading something which is in GeoJSON, please don't get phased that, okay, what is this data format? I have never come across this data format. Does it even load on QGIS or not? Because now you know that it does load on QGIS, on any GIS software, not just QGIS. It'll open in ArcGIS as well and other GIS softwares as well. So it really doesn't matter if it's GeoJSON or shapefile or anything, as long as it opens the data, it's absolutely fine. But I just want the class to get used to the various data formats that's possible. Okay, so can we go ahead? So what's your observation of this? Like, what are we looking at? Like, where is the warming happening now that we have the continents here? Where is warming not happening so much? Anyone wants to give it a try? Anyone? It's absolutely fine. Just give it a rough shot. It's absolutely fine if you don't get it.
The southern part of India looks cooler than the northern part, something like
Okay.
that.
Okay, that's a good observation. And globally,
Well,
you think-
the Arctic is warming faster, or at least has a larger anomaly.
yeah, larger anomaly. Yeah. Okay, before we go ahead, I'll also show you one more thing. Do you have this identify features thing in the this panel? In case you don't have it, and it's a very useful button, and specifically I wanted to show you this because it's a very useful button because it identifies features as what I mean by that is you can click on a feature and it'll give you some information. So if it doesn't show, I think it's in the panels. Just play along and just see like whatever it'll be one of this. Okay, it'll be one of this. So if I attributes toolbar, yeah. So it's attributes toolbar. Under toolbars, if you just click on this, click anywhere here, and just check attributes toolbar, it'll show you. And in case if you're having problem with this, again, you can just come here to view toolbars, attributes toolbar, okay, and it'll show you these options. Now, if you click on identify features, and let me just zoom in, and let me just click on any one of the boxes, okay. And you have to select this. You have to select the map because we are not interested in the vector file. We are interested in the anomaly data that we have downloaded from IPCC. Just click on this box, and you see a marker. It highlights, and you can see. So the band 1, this box, just this pixel. The box here is basically a pixel. This pixel shows the anomaly is going to be 2.8 degrees over the 50-year average, or the 1850 to 1900 average. Okay, so just like that, in a similar way, let me see. You were saying South India. So South India, let's see. Like if we zoom in, okay, so South India is showing. Yeah, I think this one will be Andhra Pradesh if I'm not wrong. So just click on the box, and it's 1.3. Okay. 2.02. So this is what an identify features button does, and it's very helpful. Before you actually get into the calculation and everything, it's very helpful to just see like how the data is stored and what numbers are there and everything.
In fact, I remember we did a story. We did a couple of stories based on this.
Yeah,
Yeah.
I did a story, and the class has to do an assignment on this. So please
Yes,
do.
that's why we're talking about.
Yeah, so your assignment is going to be based on this data. Okay, so yeah, this is one
So
of the
just
first
for the sake
GIS
of participants, it is we did stories on how coastal cities of India will be warming, based on this atlas. So you can actually get local stories from this global map.
Yeah.
Yeah.
Yeah. Also, just one thing, since ma'am said local stories. So also every map has a resolution, okay? And I'll show you properties. You come to information. So this is pixel is 1 by -1. So what does mean, I think, is 1000 kilometers by 1000 kilometers. So every box here, the square kilometer is going to be, I think, 1000 by 1000 or something like that, or 100 by 100 kilometers, if I'm sorry, my bad, 100 kilometers. Okay. So if you're going to do it's based on the resolution of the map. So if you're trying to do a district-wise story, it will be a little misleading because the resolution is very coarse for districts. Okay, but if you're doing a state-wise or a country-wide story, then it holds. So you have to be a little careful when it comes to like what you're trying to calculate based on the resolution. So I just wanted to flag this in case someone's going to do it district wise. So it might be a little misleading. The number might be a little misleading. Okay. So now the most powerful thing about QGIS is it allows you to quantify data, and that's exactly what we are going to do. So what we are going to do in this class today is first we are going to quantify this data continent wise. We want to know which continent of the 6 or 7 continents, which continent is going to be warming the most, warming at the highest rate. Okay. And by continent, I mean only the land. Okay. Because continents are just land. It's not the, so it won't have this area, just in case someone might be thinking, like, why is it not showing the highest change, which is 8.09. So the land would be warming, so the water would be warming at a higher rate. Okay. So before we go ahead, any questions before we go ahead with this calculation?
Like you showed us that polar view of the vector data set. Can we see it like that only from polar view? How
Yeah,
this map will look?
yeah, absolutely. So if I see Arctic Circle fly, give it some time. Okay, it's taking some time to load. I'll have to see what's the issue with this one.
I think let's see it later on, Puna. So
Yeah.
Sanpreet had a question. Sanpreet?
So it shows, yeah. So
Yeah.
here, this is how the polar region is going to look. Okay.
Scary.
Yes, very scary. Very
As we are going on to all the map and everything, is there any way that we can the states or the or names can come up on the map, so it will be easy to identify also?
So that has to do with the labeling. That has to do with labeling. I'll
Okay.
share. I'll share. I'll share a link with you on how to do labeling. It's not part of the class. We won't be dealing with it, but I'll share an article with you, which is very helpful when it comes to, like, if you want to just label it. Normally, what happens is I do the labeling in a design software like Adobe. So I don't need the labeling from QGIS. But in case if you're not into designing, and also, of course, you need some kind of labeling. So that's that. But normally you do the labeling when it comes to export, not when you're just seeing the raw data itself. Okay. So yeah. So now let's just go ahead and actually see, like, which continent is going to be warming the most. Okay. And in order to do that is you come to processing. Here's processing. And by now, I think you guys are familiar with processing toolbox. And I'll just delete that. Type zonal statistics. Zonal statistics. And you'll have 4 options. You can ignore the raster layer zonal statistics. What we are into is zonal statistics, just zonal statistics. Okay. Double click. Your input layer is going to be the world continents. Your input layer is so here you won't have any confusion because it already says specifically raster layer. So your raster layer is going to be the data itself, and your input layer is going to be the GeoJSON file, the world continent that we downloaded. Just one more thing. So here's the statistics to calculate. Okay, so if you click on this, if you just click on this. Now, what we are interested, these are standard statistical, terms that I think like everyone's familiar with. And if you use Excel, you should be familiar with this. So what we are interested in is just the mean, not count, not sum, just the mean. So you can uncheck all of them and just keep mean checked. And now go back. Okay. And then just click on run. And before I close this, do you see a subtle difference in what happened compared to the last class when we were trying to count the polygons inside when we were trying to count the points inside a polygon? What is that subtle difference that when you compare this process compared to the vector process? Anyone?
It's faster.
It's faster. Okay. Yeah, that's a good observation. Yeah, it's definitely faster. Anything else? We did not get the invalid geometry error. Remember? We did not get the invalid geometry error. So we are lucky that this file is absolutely fine. So it hasn't been edited in any way. So there's no issues. So that's why we did not get the error. But a lot of times, what happens is you will get that invalid geometry error. And that's when you have to first do the check validity step. And then you have to go through the fixed geometries step. Thankfully, this time we did not get the error. So we can safely close this, and this creates a file called zonal statistics. So in order to see the data, what should we do now? Anyone wants to give it a try?
Uncheck rest all and check only journal statistics.
Okay, let me uncheck everything, but does it show the data? No, it just shows this file.
Okay. We raster data, we need to put the layer there.
Okay, so does it show, like we basically need, like which continent would be warming the most at the fastest rate? So how do we see the data from a shapefile this is a virtual layer that it has created. It isn't a shapefile yet. We have to save it as a shapefile, but how do we see the data in a vector layer? If I ask a simple question, how do we see the data in a vector layer?
We have to extract it.
Attribute tables?
Yes, very good. Attributable. So now this is how you're getting used to QGIS and the ways of QGIS. These are the signs. Okay, so open attribute table. And here you have Africa. It has a bunch of other data, but what we need is mean. So Africa, the mean temperature rise in Africa would be 2.4 degrees above the 1850 to 1900 or the pre-industrial era average. That's what it means, basically, this number. And then we come to Asia. It's going to be 3.5. So Asia would be warming at a higher rate compared to Africa. Let's go to Australia. Australia would be 2.117, so it'll be lower than Asia, but I think it'll be Asia as well as Africa. Okay, great. There's Oceania as well. Oceania, I think, is this region. I think this region, that's what they mean by Oceania, even though Oceania and Australia should be the same. But Oceania would be at 1.64. Then there's South America. This is 2.25. Okay, so right now, I think Asia would be warming the most. So let's see. Now let's see out Antarctica. Antarctica would be 2.27, again lower than Asia combined. Let's go to Europe. Europe would be 3.24, so it'll be more than Asia. So here we have a story. Europe would be more. So is it the highest? Let's see. Oh, so it's going to be North America. So North America would be warming at the highest rate. So that's the story.
So while Mr. Trump denies it,
yeah,
the data is completely different.
Trump
shows the reality.
Yeah, so Trump denies this theory.
Yeah.
So these are some of the things that you can do with QGIS, with vector data, with raster data. And the most powerful thing is you can always quantify things, you can qualify it, and it's all evidence-based. It's not, you're just making things up or just an assumption. Yeah, Dipali has a question. Please go ahead, Dipali.
With respect to this data CIMP6, how much forward the projection is in time? Like how many years down the line we are?
So if you come to, if you see here, I think, so this was the simple feature that we went. If you come to advanced, I'll just go back. Oops. Okay, so let me just click on this once more. So we had gone for simple. If you now click on advanced, if you have the quantity and scenario, here you have a bunch of scenarios. Okay. So you have near term, you have medium term, you have long term, but warming at 2 degrees, it's not based on any time period. It's whenever the world hits the 2-degree mark. Get it?
Yeah, okay. Thank you.
Yeah, so that's the thing. And you have scenarios as well here. You have the baseline. So yeah, that's the thing. Any questions?
So just to make sure,
Yeah,
when the average temperature across the world is
yeah,
crossing 2 degree, and that's when we are looking at specific continents, how much
yeah,
it is
yeah,
increasing.
yeah. So whenever the world reaches the 2-degree mark above the 50-year average of 1850 to 1900, not the mean temperature of the world is going to be 2. So here's the difference. A lot of people think the mean temperature is going to be 2 degree, but that's not the case. It's whenever the world hits to whatever the mean temperature. So right now, I think if the mean temperature is 17 degree. So whenever the mean temperature reaches 19 degree or the 2-degree threshold, that's when they start calculating what's going to be the mean temperature across the world. Okay.
One question.
Yeah.
In 2024 itself,
Mm-hmm.
if you analyze the data for past 10 months in 2024, the world already breached this 1.5 degree.
Yeah, it
So-
already breached the, in fact, yeah, it
Yeah.
already breached the
So
1.5
therefore,
degree.
whether this map which we are mapping temperature wise is
Mhm.
capturing those data that which have breached, which areas have breached 1.5 degree.
You can actually check it. That's a very good way of looking and validating the data itself, because this is still a model. Okay, this is not observed. This is just model. And also, what models look into is not just 1 year. It has to be for a significant period of time. Okay, so that 2 degree has to be for at least, like, it has to become a trend, as in that, like, the world would be hitting that 19 degree, like the two. So if the world is right now, the mean temperature is 17 degree, and right now, say in 2026, and in 2027 it hits the 19-degree mark, and then in 2028 again it falls back to 18. So I don't think this data holds. But if for a significant period of time, say like for 5 years or 10 years, it keeps hitting that 2-degree mark, that 2-degree breach, then we can safely assume, okay, so the world has increased by 2 degrees compared to the 1850 to 1900 average. Okay.
Thank you.
Yeah. Any more questions? Before we now, all that is left is for us to export this map and then get into the assignment. I'll explain the assignment for you as well. But any questions before we actually go ahead and export it? Okay, so great.
Just one thing
Yeah.
before. So
One,
now that we'll be
one,
exporting
Kriti,
it.
Kriti, can you go ahead first?
Yeah, can you hear me now?
Yeah.
So before exporting the data, will you also be labeling it, or you'll
So I
that
won't
will
be,
be separately sent?
yeah, so I won't be labeling it, but I'll just share, I'll just share an article with you on how you can label it yourself.
All right.
Okay. So, by labeling, you mean like what, all the countries?
Maybe not all, but specifically say say the Antarctic area is going to be the warmest. So maybe like a sort of a pointers that okay, these are the top 5 countries or the areas or the regions
Okay,
that
so
will be the hottest.
so that you can just do with a text label. Just do with a text
Okay.
label.
Okay.
Okay, I'll show you. I'll show you what how you can do it. But before we go ahead, let me just I'll just change the projection from 4326 to my favorite, which is this. And you can see it looks much better.
Mhm.
Just give it some time for it to load. And in the
Can,
meantime, you guys
can
can also.
we apply graduated symbology here?
Yeah, I think so. So, graduated, let me see. So here, what do you mean by graduated? It's so the symbology here in rastered is a little different to the vector. Okay, so you won't find the graduated symbology here. So, but what you can do is you can check the paletted unique values and it will have all the unique values. Okay. Here we have it in classes, but if you want to show all the unique values, that's what you do, the paletted unique values, but then you'll have a problem with the legend. Okay, so always keep in mind you have to also give the legend. And if you have so many paletted unique values, the legend is going to be huge. So that's why we try to do it in terms of classes like this. And what I can do is I'll do an equal interval and just keep it to say 5. And then click apply. And just keep the label. So the label is what's going to appear, I think, in the legend as well, if I'm not wrong. So let me just try this. I think it's going to be 8.0. I'll keep it to 8. Or I'll keep it to 8.1. Now let's see. So here you have the sphere mall wheat. And how do we open, how do we get into the export mode? How do we export the map? What's the first button that we click? Anyone? Does anyone remember? Okay, I'll show
New
you.
print layout.
Sorry?
Go into the new print layout, right?
New print layout, yeah. Yeah, this is the new print layout. And you can all, if just in case if you're missing this, you can also come to project and new print layout, or just do Command P or whatever the shortcut is in Windows. And I'll save it as temperature rise. So here's the window. Here's the artboard, and we can come to add map, and we drag it. And I was talking about extents in the last class. Okay, so right now there's a lot of white space here, a lot of white space here. So what we are going to do is we're going to tweak the extents a little bit. So whatever the edge is, I think it's minus. So this is X minus. Okay, so this is horizontal. It's X minus, vertical is Y minus, Y plus. This is Y minus, this is Y plus. This is X minus, this is X plus. So what I'll do is it's 1852856.8. 1852856.8. 1852568, if I'm not wrong. Let's see. Two eight five six eight. 2828568. Yeah. So now if you, so it's going to change. Yeah. So we have, and I'll do the same with X. I'll keep the same number. Just come here and minus, just no minus sign. And here I'll do the same with Y. Y is 9522730. 9522730. 9522730. And I'll do the same with Y minus as well, except it will be negative. And I'll bring it down. And the way you bring it down is, if you want to move it in a straight line, you have to hold this and hold shift, and that's how you bring it down in a straight line, or you move it in a straight line. Okay, like this. Yeah, I'll bring it down a little more. Okay, so the next order of the day is I want a legend. Add a legend. And we have a bunch of things that we don't need. So first, if you click on the legend tool, the legend box, here's how you do it. You uncheck auto update, and then you click on this, and you And also you don't need zonal statistics. Okay. So it's still showing 8.09, not the way we wanted. Oh, so I think we did it for, okay. So it's showing in continuous. So we have to be okay with that. That's the way it is. And I'll make it double decker. And right now, we also don't need this. So we need to increase this bar. And the way you do it is if you come here, I think it's symbol if I'm not wrong. Yeah. Mass symbol height. Let's see, does it increase? Symbol width. Okay, so symbol width increases. And this is 25. Yeah. So I'll keep it to 30. I think that's good. And I'll just decrease the width. Yeah. You can also, if you want to have a stroke line or not. And I don't need any background. I would like it to be, so that's that. One more thing is, and it's always a very good practice to just play along with these things. Keep checking what all it does. What does column do? What does font and text? As you know, it's pretty explanatory. What does spacing do? So if you see, I think legend items, I think so this will increase the space above, and this will bring it down a little bit, so you can give some spacing here. And now we need a scale bar. Add a scale bar, and again it's going to show invalid. So what you have to do is map units and then fix segment width here. And I'll give a, so if anyone's asking for labeling, right, a label, so I'll show you here. This is North America. So you can write North America. So this is how you can also label it. North
So we'll
America.
have to, sir, just one question, that we will have to do it manually, or like we can also, is there a command to get it like all
Think there
together?
is a command if we have lot of labeling. Yeah, I think there is a command. I'll have to see it. But if you have
Okay.
like around 5, 10 of them, I think you can do it manually. But I
Yeah.
think there is a command for it. I'll have to see it myself. But you can just like now. So here's also how you can integrate AI into this. Okay, you can just do a simple prompt and just say like, okay, so I have so many labels, 50 labels. How can I automate it in QGIS when exporting it? Just do a simple prompt and you will get an answer. Okay. So this is how you can also integrate, and it's good to integrate it now.
Mhm.
And sorry, so I'll do another labeling here, South America. So this is how you can do that. Change this. And I'll add a source. That's going to be IPCC Atlas and ESRI. That's the shape file. That's the GeoJSON file that we used. And I'll change the font. You can change the font for all of them. You can change the font for all of you don't like this one. I think right now it's giving Academy engraved LED, so you can change that font as well if you want. And one last thing, one last order of the day is I'll have a headline for it. And the headline would be and you can also give highest rate, which would be, I think, what was the number? Let me just see.
3.4, some 3.4.
Oh yeah, 3.4, 3.4, 3.4 degree. And you can change, sorry, just style it a little bit. So we'll have 3 decor and we'll make it center and change the font size, or we can actually just keep it to 1. Yeah, I think I'm good with this. And let's change the font to Georgia. Change the font size. 22 is good. Yeah. So now I have a good looking map, which I'm happy with. You can always play along and, make it look better. But I think I'm happy with this. Also, in case if someone finds out, if they can, instead of this continuous legend, if you can give a class, then please let me know, or I'll try to look it up myself. How can we divide it into classes instead of a continuous legend bar? Because that's what we did here. Here, if you see the when we're trying to do, we had a class here. So I would like that to be reflected here as well. But anyway, I'll see it myself. You can find it, or if someone can find it, please do share it with the class, and that's how you help others as well. Be a good
So,
Samaritan.
Pulaha,
Yeah.
I had just one simple query. So
Yeah.
now we have this map that shows the temperature scenario.
Mhm.
Now suppose I have data on projections, say for fire activities. Okay.
Sorry,
Well,
what?
suppose I have data
Mhm.
again for the same scenario
Uh-huh.
on forest fire. It's an assumption. Okay.
Yeah.
Now, can I overlay that on top of this?
You can overlay that, but we also have to see if, I mean, is it a direct correlation or not?
Okay.
Because a lot of people
Suppose
might just
it's
flag it.
hypothetically, suppose there is something. Okay, so
Yeah.
that's
So yeah, I get what you're trying to say. If
yeah,
say there are 2 layers to it, okay.
yeah,
Doesn't
exactly.
have to be forest fire, but at
Yeah,
least.
something else, anything could be, yeah.
So what you do is basically you play along these layers. You bring one on top of the other,
Okay.
and then
Yeah.
you have, see.
Yeah.
So if I
Got
bring
it.
the lunar certificates down,
Yeah, yeah.
it vanishes. But if I bring it on top, then
Okay.
we have a
Got it.
layer.
Got
So
it.
you just have to play along with the layer. It's all about the layers game here
Yeah.
now. You want to do a multivariate analysis, which a
Yeah.
lot of people were asking me.
Yeah, that's what.
That's how you go about doing it.
Yeah.
And if you change, also just one thing before I export. So if you see, if I check it, okay, and if I hit the refresh button, so it will show the existing state of the artboard. Okay, in case you say you make changes to the artboard, it doesn't necessarily mean you have to start all over again. All you have to do is just hit the refresh button and it will show you the current state of the artboard like this. So if I just uncheck it now, and now if I hit the refresh button, so this is will show the current rate, the existing state of the artboard. And now all we got to do here is just hit the export as image. It's a PNG format, temp price. That was the name I had given for the layer. And just click save, save. All these things are like at what resolution you want to export and everything. Save. Okay, Kriti raised the hand. I'll just answer your question. Let's just see how the map looks, and I'll just answer whatever questions, whatever queries you have. And once you get this green button, that means it has been exported. Your export has been successful. So now let's see. See, this is how your map looks. Okay, yeah. So please go ahead, Kriti. Kriti, I think you're on mute or.
Okay, you have to unmute yourself.
Yeah. Can you hear me now?
Yes.
So maybe as somebody who's just starting in this field, I just want to know, like, how do you correctly, like, of course, making this is separate. We'll maybe learn it by doing it multiple times. But how do we read the data correctly in terms of like, can you go to the image that we've just exported, which has that labeling?
Yeah, yeah.
Yeah. So here, when you say that the temperature rise compared to 1850 to 1900, now from the bar that says 0.63 to 8.09, like what is the right way of maybe say interpreting the data or reading it, maybe like making it more understandable to a layman that what exactly does this image talk about? Is there a right or wrong way of maybe, right way of explaining?
See, well, it's a good question, and that's always a challenge for anyone. Okay, to make a layperson understand what data we are dealing with. And there is no, I'm really sorry to say, but there's no other way out apart from, uh, the words that you choose. Okay, just make it very simple. Just make it very simple, and it's always good to have feedback from the person you are showing. Like, is it making sense or not? Okay, it's always
Okay.
is
Just one thing that because of course through this I've been reading a few articles on D2E and I do see a lot of these maps. So if I just see this map now, of course we have worked together, so I know that it is talking about the temperature
yeah,
rise and everything. But if
yeah.
I just see the number 0.63, so as in for maybe for my better understanding that how do I make sense of it in terms of that this is like by 0.63 degree that we are talking that this will be the increase to 8.09 degrees of the temperature.
Yeah, yeah,
That's how, right?
yeah, yeah.
All right, all right.
Yeah, I mean, so we have to be very careful with the words we choose. It cannot be any jargon, okay? Temperature, whatever they're trying to say. It cannot be so your legend always has to be in very simple terms. The scientists might use their own terminology, okay, but they're dealing with a scientific world. But say like me as a journalist, I have to be very, very simple with the words that I use, or I try to at least, because we're dealing with very heavy topics that we also need to explain it to an absolute layman. Okay, so we always strive or try to make it as simple as possible. We don't know if we are successful or not, but all we can do is we can keep trying until like people actually get it. So that's the only way we can make sure to make it as simple as possible.
Thank you.
Yeah. Any more
Yeah,
questions?
one question from my side. One actually small point I want to make.
No problem, sir.
Overlaying of fire data over the temperature data will not work because
Yeah.
80 to 90% of the forest fires are anthropogenic in nature.
Yeah. Yeah.
Okay. So therefore that will not work. So we should not try that. And but thing is that we can do one thing. If we can have remaining 9 to 10%, which is either means not anthropogenic in nature or lightning struck or something else reason, then we can do overlaying of that. So it will be very clear that carrying 80 to 90%, which are the areas which are more vulnerable to the other factors than the anthropogenic.
Yeah. So what sir is trying to say is basically we have to be very careful with
Cautious, yes.
the correlations we are coming up with. When we are doing multivariate analysis, like where there are more than one variable, okay, like again, I will go back to the Joshimat.
Well, the purpose was just to say that we can overlay two different kinds of data sets.
Yeah.
You know, if you're very clear about the
Yeah.
studies, it was just an example. Otherwise,
Yeah. So you have to be very, very careful. In this case, we had like three. We had roads, we had buildings.
that's a
and
perfect
finally we
example of
had-
what we're talking about. Yes.
Yeah, and finally we had where sinking is actually happening.
Yeah.
There's also topography playing a part. If you can see these, this is all topography. So topography also becomes the fourth variable to it. They haven't explicitly said that, but so you have to be very, very careful. Okay, so now going ahead, and the final thing is the assignment. So I'll explain it, and then we'll also give it to you. You will get a mail from us explaining what we require from the participants. But let me just explain it. So right now, what we did was we quantified the continents. Okay. What you guys have to do is now get the country, the country shapefile from Natural Earth, specifically from Natural Earth and not ESRI, because of a simple reason that ESRI, the resolution is way finer. So what happens is if you're going to use the ESRI shapefile or the GeoJSON, what will happen is when you're doing the quantification, they'll also take into account the water pixels. You might not get it now, like what is the why this problem is going to happen, but the numbers will be very misleading. Okay. So what I would like you to focus on is get the country shapefile that we have been using, the Natural Earth, and then quantify the numbers. And then we don't want the raw data like this map that we just exported. We don't want that. What we would like is a choropleth map or a heat map. Okay, a heat map based on the data that you quantified. So what your final map is not going to look like this. Okay, your final map is going to look like the one that we did, the treatment that we gave to the fire activities, if you remember. And fire activities, I'll show you. I think we had done it, the fire map. So your final map will look something like this, and the data will be based on what you quantified, what you quantified country-wise. Okay. So that's what we are looking at. We are not looking at this like this quantified, we are not looking at this raw data map. We are looking at this quantified choropleth map.
The scenario is 2 degrees Celsius.
You can do it at 1.5. So we'll give. So yeah, it can be 2 degree. It can be 2 degree. So we'll give it to you. You will get a mail from CSE, listing out all everything that we would require. Okay.
So just to simplify, so this map that you have done right now is at continent level. Okay.
Is it continent level?
Yes.
Yeah.
But the participants have to do it at country level.
At country level.
Yeah. Okay.
Country level and a choropleth map or a heat map. Like this one.
Yes.
Okay.
Yeah.
Yeah. So was I able to explain the assignment to everyone?
I wanted to ask, so country level means any one country we have to pick
No.
we have
So
to
globally.
globally. Okay,
Yeah.
fine. Understood.
Countries, as in like countries. Yeah. Yeah, so Dipali has a question. Please go ahead.
Yeah, just to get a clearer understanding. So our base data is the same.
Your?
Base data, the CIMP6,
It's going to be
that
IPCC
is the
only.
same.
Yeah, it's going to be IPCC. Either it's going to be 1.5 degree or 2 degree. We can decide. I'll decide on that, and you'll get a mail from us listing what all you have to do.
Okay, thank you.
Yeah, the data remains the same. Yeah, it's IPCC data. Yeah. Any more questions? Okay, so I'll stop my sharing.
A second, Kiran.
Yeah.
So thanks everyone. We hope you found these sessions interesting and useful. One last message. The last date for the submission of projects is being extended till September 21st. We do understand people have doubts. Most of us are beginners, so you still have 2 more weeks. Till almost more than 2 weeks. So till September 21st, you can submit your assignments. If you have more queries, just feel free to write to us, and we'll answer them within 48 hours maximum.
Ma'am, I just have one question.
Yeah.
All the modules are there, which links you have shared with us. By what time those modules are available?
We usually make them available at least for another 1.5 months. Don't worry, they'll still be there. So
okay,
you can still
because
access them.
if I say about myself, I am still on the module 1. So
no, so don't worry. You will have access to all the modules till at least till end of September at least.
Okay, thank you, ma'am.
Any more doubts?
Okay.
Yeah.
Thank you so much, everyone. Thank you so much.
Thank you, everyone. Okay, thank you.
Thank you.
Thank you.
You're welcome.